Hi, in this video I'm going to show you how to complete the square, which is now a topic on the IGCSE and just a really important and useful thing at all levels of maths, something that keeps cropping up over and over again. We'll use a method that actually solves any problem. Okay, so sometimes you learn this in different steps for easy ones and hard ones, but I think it's better actually just to do them all at once. It's not too hard to do it this way. So what we mean by completing the square is we want to write a quadratic in the form a times x plus b squared plus c, where a, b and c are numbers that we need to find, constants. So really it's equivalent to saying, can you find a, b and c in this problem? Okay, so for example, if we had x squared plus 4x plus 5 as our original quadratic, then the completed square form would be x plus 2 squared plus 1. And we'll see how to work this out in a second. Or, if we had 2x squared minus 3x plus 5, that would be 2 times x minus 3/4 squared plus 31 over 8. Okay, we'll see how to work these numbers out in a second, but I've just rewritten the quadratic so they're in the form here. In the first one, a is 1, b is 2, and c is 1. In the second one, a is 2, b is minus 3/4, and c is 31 divided by 8. Okay, and notice these a, b and c are not the same thing as the a, b and c in the quadratic formula, right? There's another, don't get confused with that. The a, b and c mean something different in that context. Here they're the constants in this form. Right, so to do this for any quadratic, we can just start by multiplying out this form that we want to put our quadratic into. So this would be the same for any time you did the problem. Okay, so this is a times, now you have to do x plus b all squared, so that's x plus b times x plus b, that gives you x squared plus 2bx plus b squared. Multiply that out more slowly if you need to, and then we've got our plus c, so this is a times x squared plus 2abx plus ab squared plus c. Okay, now let's say I've got a particular problem now. Okay, so let's take that first one we were looking at, x squared plus 4x plus 5. So finding the constants that we're looking for, a, b and c here, to put it into this form is the same as making this expression equal to this one for the right values of a, b and c. So let me just recolor some of these items and write the expansion like this. So the x squared and the x are present in both, and we've got the coefficients labelled here. So this method here is called equating the coefficients. To choose a, b and c, just look at each coefficient one by one and match them up. So here I've got something times x squared. Now you could think of this as 1 times x squared. That's got to be the same as a times x squared, right? So that just means that a has to be equal to 1. Right? Now I look at the next one, I've got 4x and 2 times a times b times x. So if those coefficients are going to be the same, I need 4 to be equal to 2ab. Right? But look, we've just found that a is equal to 1, so this a is 1, so that means that 4 equals 2b. 4 equals 2b gives us b equals 2. And finally, for the last one, I've got 5 is equal to ab squared plus c. Okay, but I know what a and b are now, right? So 5 is equal to 1 times 2 squared, which is 4, plus c, so that gives me that c is equal to 1. So I found the three numbers that we wanted, a, b and c, and we come to the conclusion, as I said at the start, that x squared plus 4x plus 5 was equal to a, so that's just 1, I don't really need to write that, but let's put it here for completeness, times x plus b squared, which is 2, so 1 times x plus 2 squared, plus c here is 1. Okay, and we wouldn't usually write this one, but it's still in completed square form. Right, so I've completed the square on x squared plus 4x plus 5. And the nice thing about this method is it's just as easy to do this for any other quadratic. It doesn't matter if it's got just 1x squared or 2x squared or more. Sometimes you learn to do them separately, but it's easier just to have one method to do all of them, I think. So let's do the same thing again. This time we're going to apply it to 2x squared minus 3x plus 5. again, I look at the x squared coefficient and I just get that a equals 2. I look at the next one, which is now minus 3. Remembering we've got to incorporate the sign into equating these coefficients. So I have minus 3 equals 2ab, but again we know what a is here. So minus 3 equals 4 times b. That gives us b equals minus 3/4, which is a fraction, which is fine. And then finally I have 5 equals ab squared plus c. So I've got to be a little bit careful substituting my fraction in here, but again I know a is 2, b is minus 3/4, so I'm going to do minus 3/4 squared plus c. And you can work out what 2 times minus 3/4 here is. It's 9/16 times 2, so that's 9/8. So we've got 5 equals 9/8 plus c, so 5 would be 48, so that gives us c is 40 minus 9, which is 31 over 8. So although fractions came into this and that made it a little bit harder, in principle the method here is exactly the same, and we find that the completed square form of 2x squared minus 3x plus 5, that would be equal then to 2 times x minus 3/4 squared plus 31 divided by 8. Okay, so a bit harder with fractions, but the form is the same. I've just found these three numbers and substituted them in. Okay, let's do another one. We've got 2x squared plus 8x minus 15. So this time, again, we get 2 equals a, looking at the x squared coefficient, so a equals 2. For the x coefficient, we've got 8 equals 2 times a times b, but a we know is 2, so this is 2 times b, that's 4b, so I get b equals 2. And I have the last coefficient, minus 15, equals ab squared plus c, so minus 15, we know a and b, so this is 2 times 2 times 2, which is 8 plus c, so that gives us c equals minus 23, and that shows us that 2x squared plus 8x minus 15 equals 2 times x plus 2 squared minus 23, and we're done. So once you've know how to do this, as long as you can do this multiplication out at the start, the whole process becomes quite repetitive, and you can deal with even the trickier cases just with the same method. So it can be quite confusing if you use other methods when you've got a negative number in front of the x squared, for example, but here the method doesn't change. I just have minus 3 equals a, and then I look at the x coefficient here, and I've got minus 5 equals 2 times a times b, but a is minus 3, so this is minus 6 times b, so that gives me b equals minus 5 divided by minus 6, which is just 5 divided by 6, or 5/6, and then I do ab squared plus c equals the 2, so I've got minus 3 times 5/6 squared plus c equals 2, so here I'd have 25 over 36, so that's times by 3, 25 over 12, so minus 25 over 12 plus c equals 2, so c equals 2 plus 25 over 12, which is 49 divided by 12, because 2 would be 24 divided by 12, and 24 plus 25 is 49. So again, can be a much harder example, this sort of thing, if you're using other methods, but here I can just write straight away then that minus 3x squared minus 5x plus 2 equals minus 3 times x plus 5/6 squared plus 49 over 12, and we're done. So a bit harder with fractions, but exactly the same method. So hope that was useful. Should be able to now go away and complete the square on whatever other examples you need to apply them to. So don't forget to like the video and subscribe if it's been useful, and watch out for some more videos. I will keep making them and upload them as often as I can.